and then plus 3. Then combine any like terms, 2 to the x. What do we have here? Can these be combined or not? Yes.
So it would be 2 to 4.
There's 4. Yeah, there's 4 of the 2 to the power. Now you can put that in bracket if you don't like my dot. You can put it like this if you want. That's fine. Probably the book answers will use the bracket, not the dot. But yeah, because sometimes 3.2. Does that make sense? So there's 1 of them here, and there's 3 of them here, so there's 4 of them in total. Now, if you prefer brackets, that's what I was saying. So there's 1 of them here. If you ever want to do this, you don't need to, but you can.
And to solve this, you can make it a quadratic.
Well, yeah, you can. Yes, this is a quadratic form. We'll look at that in a minute. There's nothing that doesn't equal anything, so I can't solve it. But I could find its roots. Yeah. Okay, so I won't do the second one because that'll just be. Well, maybe I will. Let's just bed it in. 7 to the x plus 7 to the negative x squared will be this times itself. So we would get this times this gives add the powers 2 x's. This times this add the powers gives, like in the starter we just had, would be 0. So that gives 1. 7 to the power 0 is 1. And then these times each other, add the powers also gives another 1, because add the powers, 7 to the 0 gives 1. And then the last one is 7 to the minus 2x. So these just cancel, yeah, do they? Do they?
Yeah, probably. Because it's plus.
Well, let's 7 to the 2x plus 7 to the negative 2x plus 2 is a slight simplification, but do these just cancel each other out is the question.
Oh no, because as a fraction it'll be 1%.
Yeah, so you could think of one example. If x was 1, what would the value of this one be? What would the value of this one be? 1 over 49. Do they no, they don't cancel out in any way. No. So anytime any exponential doesn't give a negative answer, does it? Can you get a negative answer out of an exponential? Like 2 to the power, 2 to what power gives a negative number? That's what I want to know. I suppose, yeah, the first place you would think of maybe logically is -2, but then you think, oh no, that's the same as 1 over 2 to the 2, which is just a fraction. Yeah, so a negative power gives a fraction. It doesn't give a negative. So there's no way to make a negative, is there?
Only if like the number rather than the power is negative.
Oh, if the base itself is negative? Yeah, so if you get, yeah, that's possible, yeah.
What if we put it inside of that? What if we put quadratic inside of that? But no matter what number, it's still negative.
Yeah, there's no way that any power can make a positive base negative. It'll make it a fraction, but it won't make it negative, yeah. Okay, at the moment with the laws we have anyway. Okay, so working in reverse then, we have to be able to do that. Of course, the reverse, so that was it fully simplified. Working in reverse, we have to be able to factorize when we see, so this is the same as if you have something like this, you have to be able to go back and put the brackets in and factorize it. So we have to do the same thing when there's exponents, when the x is in the exponent. So what would this be factorized?
2 to the power of 2x.
Okay, so 2 to the power, just 2 to the power 2x. So if you want to factorize, you want to find a common factor or 2 things that multiply to give this.
4 to the power of x plus 3 times 4 to the power of x minus 3. It's
4 to the power of x. 4 to the power of x, but that would mean 4 to the power of x times 4 to the power of x would be 4 to the
sorry, 4 to the power of half of x minus 3 plus 4 to the power of half. No, it's 2
Oh, yeah. It's 2 to the power of half x plus 3, and then 2 to the power of half x minus 3.
Okay, so yeah, if I replace this with x squared minus 9, what would just as another factorization, what's the factorization of this? X plus 3, x minus 3. The difference of 2 squares, isn't it? Okay, so there's no middle term. How did we get here from there? we went, okay, that's x to be squared minus 3 to be squared, the difference of two squares. So this is also the difference of two squares, 3 squares. And what is the thing that is squared here? Yeah.
4 half x.
Would that make the above? X over 2 squared?
Yeah.
I think it would, yeah, wouldn't it? Yeah. Okay, so what we put? 4x over 2 plus 3 and 4x over 2 minus 3. Is there another way of doing that? Would 2x work instead of 4x over 2?
Because that would be a different.
2 to the power of x? What's 2 to the power of x squared?
Oh, 4
2 to the power of 2x, yes. Which is
4 to the power of x.
which is also 4 to the power of x, yes. So I probably would have gone this way, but I'm not. Your way, you just came there. That's also correct, but maybe it's nicer to write it this way. So 2 to the x and
It does the same thing if you just like get rid of the exponent fraction. Because like x over 2.
oh yeah, it's the same answer, yeah.
4.
Yeah, absolutely the same answer. Just some people might prefer that 2 to the x plus 3 and 2 to the x minus 3, just a little tidier than this.
Does it matter the example?
No. This probably is the more simplified version because you can do something to the number here. You can apply in this half to the 4 and square root the 4. So there's a bit of simplification that could be done. So this would probably be a more simpler version. So I've said fully simplify, maybe. But you have factorized it, yes. Okay, so that's two ways. So notice that if there's no middle term here and you notice that that's a square number, this is a square number, that we can apply difference of two squares. Let's do one more and then get you to do a few. So what's this other example look like? The 9x, this one, 9 to the power of x plus 4 to the 3x plus 4. What type of equation does that look like? Looks like a quadratic, yeah.
So 3
You see that?
power of x.
But this one's
Plus
also
2
like a
bracket square.
like nice. It's like sort of square.
Yeah.
Yeah, it could be. Yeah, it could be a perfect square. Yeah. So
3 to the power of x.
yeah, so this can be rewritten. Well, 9 is 3 squared. Yes. So that's 3 squared times x, which is 3 2x, plus 4 3 to the x plus 4. Now, if you don't like the way it's currently written, there's an algebraic trick or a way to make it look nicer. You can just say, all right, I'm going to, instead of writing 3 to the x in future, I'm just going to write the letter a. And then at the end, I'm going to put it back in. You don't have to do this. So I'm going to rewrite this. It's called exchanging the variable. So this is a squared plus 4a's plus 4. This might look easier then to factorize. You have a times a, 2 times 2, plus times plus. Oh, that's a. Oh, that's a plus 2 squared. But of course, you weren't dealing with a. You were dealing with 3 to the power of x. So I can put in 3 to the power of x plus 2 squared, which you might have seen already. But maybe with some of the more complicated quadratics, it's nice to swap out the variables for something that easier. For instance, later on when we deal with trig identities, you're going to have something like sine squared x plus 3 sine x plus 4, which is just a bit annoying to look at, but it's just a quadratic where you say a is equal to sine x, and then that becomes a squared plus 3x, or 3a, sorry, plus 4. And that's an easier thing to factorize, but you know you're always dealing with a being sine x. So that we'll come up with that later, but that's just an example of where you can switch. Okay, you guys do some now. There's a bunch of questions. I think you're probably okay at expanding. If you're all getting 4, at least 4 out of 6 on the starter.